going live, going live, going live, going live, going live, going live. Good evening, Hussain. Good evening, Prakriti. Good evening, all the Doraemon students. We all are Doraemon students here. I'm ending this. Okay. Return to the meeting. Resume share. So, students, I have shared you in front of you all the things. I started the live streaming. You can see on the YouTube also. Who are the students who want to see on the YouTube can see there. First of all, we will start here. Okay. So, oh, sound, I think it's not okay or what? Are there a sound issue? Okay, I'm launching that thing. What do we say? Poll. Shinchan is in front of you. Shinchan is teaching you. So I'm launching the polls. I have launched the techno poll. Students, edutech poll I've launched. Edutech poll. Am I audible to all you clearly? Yes or no? Is my shade screen visible to all of you? Yes or no? Yes or no, students? I'm spotlighting myself to all of you. Yes. So I think the audible is fine now. Now it's fine. It's very much clear to you. I don't know why one person is saying it's not fine. What's the reason? All of you participate in this technical checkup, brother. Otherwise, how we can start the class? Without the technical checkup, how will start the class, students? What's the way? Okay, let us put now today a new virtual background here. We'll put a new virtual background. Not Shinchan's, but we'll put Doraemon. Somewhat Doraemon will put. Hold on. Yes. What has happened? What is coming? Am I audible or not? Please reply fast. Don't waste the times. This is fine. That is fine. Huh? Okay. So let us study now. Yeah. So I'm removing this pole and pole. Audible. Good. If it's audible, then that's very good. Students. Very good. Okay, students. So today we'll be starting. See, can anybody tell me where we left the yesterday's class? Can any one of you tell me where we left at the yesterday's class? Yesterday's class, where we left? Any one of you? Any one of you? Can you tell where we left at the yesterday's class? Please remind me this thing fast, students. Put a text in the chat box where we were at the yesterday's class. Last class में क्या किया था? Okay, let me remind you what we did in those classes. Current. Yes, electric field length. Very good. Okay, students, I'll remind you. I'll revise few of the things from the previous class. Then we'll proceed. What I will do, I will revise some of the things from the previous class. Then we'll proceed with the brand new topic. That is today's topic. Okay, we'll do this. I am switching off my camera because there are some things here. So Doraemon is gone now. Doraemon is students gone now. Doraemon. Okay. Okay, students. Let us start it. So, tell you one thing. So, students, if we talk about the previous class, na, if we talk about the previous class, let me take the white pen first. Yes. So we started with, see, you people have started with charge and all these things, but I'll revise you only those things which we have studied in the previous class. Okay. So students, what we studied in the previous class, we started with what? We started with electric field intensity. In the previous class, we started with the electric field intensity due to a single charge. We have seen like this, suppose if Q charge is there. Okay, let me show you the whiteboard. It will be good here. Suppose, my dear students, suppose we are having a Q charge like this. Okay? And at a R distance, there is some point which is known as P. If at this point, we need to find the electric field intensity, we say like this: electric field intensity at this point P is equals to K Q by R square. This is the electric field intensity at this point. Okay? What I will say? I'll say the electric field intensity at this point is this. Okay? Or suppose if I take a R1 point where R is R1, intensity will be same KQ by R1 square. So that was a generalized formula for you. This we have seen. That then what we covered? Then we have seen that if in a space there are system of charges like this: Q1, Q2, Q3, Q4, Q5, Q6. And if at a certain point, say P, which is at different distances. So P is at a distance R1. From Q5 it is R5. From Q3 it is R3. From Q4 it is R4. And from Q1 it is R1. And from Q2 it is R2. These are different distances. These are different distances. So if they ask from you that due to these multiple charges, what is the electric field intensity at a particular point P? Then I told you how was the way to write that net electric field intensity at a particular point is given by KQ1 R1 square R1 cap KQ2 upon R2 square R2 cap. Symmetrically, you will write the net intensity KQN by R. Sorry, it was what charge? 6 R6 square R6 cap. This was the way. Yeah, very good. Tripti says vector sum of all. Tripti, you are right. Vector summy of all. Check. Fine. So we covered two topics in the previous class: electric field intensity due to single charge, single all the way. And then we covered the electric field intensity due to multiple charge, multiple. Then we understood two more things, that there is something which is known as electric field lines. Okay. And we have seen that if you draw tangent to a curve, this gives you the direction of the electric field intensity. two important concepts, star concepts. Where is my star? Star 1, star 2. Two important concepts which we studied was this, that if a source charge is plus Q, electric field lines will be going away from the source charge like this. Okay? And if the source charge is negative, electric field lines will be towards that negative. Sorry, it's negative. No, I'm sorry. So if it's negative, electric field lines will be towards it. For a positive charge, electric field lines are away from it. For a negative charge, electric field lines are towards it. Let me see how many students have joined today. These are the numbers, these are the numbers, these are the numbers, these are the numbers. Okay, I hope all of you understood. Is it fine, students? Is it fine, students? Akila, Anusha, Dev Gowda, Dani, Shwari. ठीक है? समझ में आ गया? So we can proceed for the new topic. So are you ready for the new topic, students? Yes or no? Yashashwani, Akhila, all of you I'm asking. Akhila, Anusha, Jansi, Ishwari, Kushal, Mantan, Kali, Nikita, Purnima, Purva, Prapti, Pragita, Sangeeta, Sadeshwari, Shirsha, Sneha, so many names. Natish, Sachin, Priyanka. So all of you are ready? We have completed this previous thing. We have gone through the previous thing. Yes, very good. Let us move now. So write in your notebooks a very fresh topic. So electric potential will teach. I'll go with electric dipole direct. DD direct. This is DD direct. Doordarshan. Okay. So I will go direct. Write the topic in your notebooks. Electric dipole. Electric dipole. It's not dipole. It's dipole. Write a very fresh topic in your notebooks. Electric dipole. Okay. First of all, we'll understand this thing, that what is the meaning of this topic, that is electric dipole. Iska matlab kya hai? What does this actually mean? Electric ka matlab hota hai, which is something which is connected with electrons. Or more precisely, if I say something which is connected with the charges. डाइपोल का मतलब होता है, वेरी गुड तृप्ति वेरी गुड. डाइपोल का मतलब होता है कॉम्बिनेशन ऑफ चार्जेस. डाइपोल का क्या मतलब होता है? कॉम्बिनेशन ऑफ चार्जेस. सो दीज आर चार्जेस विल से प्लस माइनस. ठीक है? सो प्लस क्यू एंड माइनस क्यू. सो नाउ वी कैन कमेंट लाइक दिस कि व्हाट इज द थ्योरेटिकल डेफिनेशन ऑफ इलेक्ट्रिकल डाइपोल. Now we can, Jansi, good. Now we can comment that what is the theoretical definition of electrical dipole. We say like this: if we are having a combination, what we are having? We are having a combination of, say, negative and positive charge. Okay? And this combination of negative and positive charge is situated at a very small distance, which is equals to some d distance. Here this d distance is given equal to 2a. Okay, so we say like this: if we are having a negative and a positive charge, and these two charges are situated at a very small distance, d equals to 2a. Okay, such a system is known as electric dipole. Such system is known as what? Electric dipole. I hope it's clear to all of you, na? So here it is given like this: there is a negative. Oh, who is this? I will send you out. Don't create noise in between. Suppose we are having a charge minus q and plus q. And here it is given these charges are situated at a distance 2a from each other. Such a system is known as electric dipole. And this yellow point is known as the center of the dipole. What does it mean? This yellow point is known as the it's known as the center of the dipole. It is known as the center of the dipole. Okay. Because it is at a distance of a from a negative charge and at a distance of same a from the positive q charge. Who is this student? You are JNV Kadau students, hai na? So I am sending you out. Here I am clicking and I have the option to send you out here. So now you ask the ID from the sir only. Yudheshwara, keep yourself mute. Otherwise, I will send you out. You will not able to join. You have to ask separate ID from them. Then you will be blocked from Zoom. Okay. Don't do like this, yeah. You are grown up people. Grown up, matlab grown. Minus Q. So there is next slide is this, which says you like this, that if you are having a system of a dipole that is a minus Q charge, students class is up to 5 minutes will have a NPS pole. Okay? Up to 5:50 only I'll take the class. Then we'll have NPS pole. This is a negative charge and this is a positive charge. Just by looking at it, we can say this is a system of electric dipole. This is what? This is a system of electric dipole. Okay? And now suppose if we need to find the dipole, so there is something which is associated or connected with this. That is something which is known as dipole moment vector P of an electric dipole, which is connected with this. It is given by this. P is equals to charge into 2a P cap. Okay? So this is the charge and this is 2a. So we define dipole moment vector like this. Tell me how you will define that electric dipole moment vector. Wait, students, I am joining. Some issue occurred. Yeah. So we were here, no? So now the question is this, that how you will define electric dipole vector magnitude. So we say like this, multiply any of the charge magnitude with the distance between these two charges. So I think I need to remove this person. I don't know who is this. Whose mic is on? If I can see here, mic on is Siddheshwara, and whose mic is on? I'll remove you. Now it's fine enough. So dipole moment vector P of electric dipole is defined as what? This. That is charge multiply the distance between them and direction. So there is one very beautiful concept which is connected to this dipole moment vector direction. It has been said like this, that we usually know this thing, that electric field lines originate from a positive charge and terminate at negative charge. This is the direction of electric field line. We know this. This is the direction of electric field lines. Okay? But the direction of dipole moment vector magnitude is this only, that is q into distance between them. Positive it is, algebraic. But direction of dipole moment vector is always and always from negative to positive. So this is, we can say P cap is negative of electric field direction. Remember this. This is a concept. Students, you can note down this concept in your notebooks. Dipole moment vector is anti to the electric field vector. Remember this always, students. Dipole moment vector is anti to the electric field vector. Is anti to the electric field vector. So now, students, we have completed two things, by the way. We understood that what is theoretically we understood, and also we have seen that what is the meaning of electric dipole. है ना? क्या देखा? Minus. Students, remember these things. I'll ask you the question now. We'll solve the questions now. This is positive Q situated at a 2a distance. We also studied what is known as dipole moment vector. We have studied this also. That what is dipole moment vector? It is like this, Q2A P cap. Okay, then now it's time to go for the physical significance. But let us understand, dive deep in this concept and understand this thing, that what actually is the meaning of this thing and where we can apply this. Basically, this topic that is physical significance, falls under the application of electric dipole. This physical significance falls under the application of electric dipole. Okay? Let us see this. So I hope you have heard the name of polar molecules. Can anybody give me the examples of polar molecules? If you know the meaning of polar molecules, then I will explain. Can anyone reply here the meaning of polar molecules? In the chat box. HCl, very good. So first of all, let us understand that what are these polar molecules? Who is doing this disturbance in the class? I have to do. Dev Gowda, please don't. Yeah, good. So, Jency says this. Good, Jency. Good, Tripati. So let us now understand the polar molecules. See, these are the molecules where the center of the negative charges and of the positive charges do not coincide. What are these molecules? These are the molecules in which the center of, so we can say, suppose we are having a room. Suppose we are having a room. In that room, there are many people. There are a set of positive peoples. What is there? There is a set of positive peoples and there is a set of some negative people. So for the case of polar molecules, we say like this, that center of, you can say mass or gravity of the positive will not coincide with the negative. So that's the points you can understand. If you want to remember like this. So now let us see an example. Understand like this, the theory is this, the polar molecules are those molecules in which the center of the positive and the negative molecules do not coincide. What is the meaning of coincide? It means at the same place. And one more thing, they are having some permanent electric dipole moment. It means the dipole moment vector is not equals to 0 for polar molecules. Remember this concept. This is branded concept, branded. This is what branded. I mean, remember this concept that electric dipole moment for a polar molecule is not 0, even in the absence of electric field. This is what H2O. This is what, students, this is H2O. This is what, this is oxygen. This is hydrogen. Okay. So we say like this. Now let us understand. Okay, that's given to you here. I told you that H2 is polar molecule. But if you really want to check, are the given molecules by the teacher or someone who want to check you that really you are having the knowledge or not, are these molecules really polar or not? If you want to check it, check this out. Pause the way. So oxygen is basically electronegative element. Okay? You know this thing. Oxygen is what? Electronegative element. So it will pull the electrons toward itself. So for with respect to one hydrogen, this will be having del negative. This will be del positive. So this is also OH. So this will pull it electrons itself. So this will be del negative. This will be del positive. Hai. So we know the dipole is what? Dipole moment is what? It's minus Q plus Q minus say positive. We know this thing, opposite to the electric field direction. Similarly, here also the thing will be same. If I show you, individual dipole moment vectors will be like this. And we know if you're having two vectors, say A vector and some B vector, which are at some angle theta. So net sum will be here. Similarly, for this also, net P net will be here. This is a net dipole moment vector. Remember this, students, always. This is a net dipole moment vector. Remember this always and always and always. This is what, students, this is net dipole moment vector. I hope it's clear. Okay. So we can check like this. If the molecule is given to us, just find P net of the molecules. If the molecule is given to us, just find P net of the molecules. Okay. If it is something, we'll say these molecules are polar molecules. What are non-polar molecules then? What do you say? What do you non-polar molecules? See, these molecules are जो भी polar का definition है, whatever the theoretical definition is for the polar molecules, just it is reverse of the definition of the polar molecules. So what are the points which were contained in the polar molecules? Let us check it out. So we know this, we knew this thing. Polar molecules are those molecules which are जिनका center of the negative charges and center of the positive charges do not coincide. And also these are having some dipole moment. It is never equals to 0. Okay? So iska anti, just put mirror in front of it. So we'll get the result for the non-polar molecule. Just kidding. Don't do that. Just for understanding the things and remembering the things. Just remembering the things I'm doing this. Okay. So we say like this. Non-polar molecules ka, it is like this. Ki center of negative charge will coincide with the center of the positive charge. And dipole moment vector will be equals to 0. So this is the definition of non-polar molecules. I hope it's clear to all of you. So now let us see the example. Let us see the CO2 molecule. CO2 mein oxygen is more electronegative than carbon. Here also this oxygen is more electronegative with respect to this carbon. So what's going to happen is this oxygen will pull the electrons towards itself. This oxygen will also pull the electrons towards itself. Now if we check out the net dipole, what's going to happen? We know if negative is this, if this is positive charge at some distance, dipole vector will be this. And if we sum both of these vectors, we know this thing. If there is some vector, say 2 Newton force, and again 2 Newton force, if we add both the vectors, this is 2 I cap plus minus 2 I cap. This will be 0. So here the net dipole moment is, students, 0, 0, 0. I hope it's clear. So this is the way how you will check the molecules. Very good, Tripti, very good. Students who are answering, they are very much concerned, very much serious about their studies. It is good. Okay, I hope it's clear to you. Now let us check for CH4. CH4 means methane. H, tetrahedral geometry. This is having tetrahedral geometry. है ना? So इसमें कैसे होगा? We'll say net will be coming here, one net will be there. So P and P will cancel each other. P will be equals to 0. Yes. So students, are you ready for the challenges? Are you ready for the questions to do yourself? Reply in the chat box, yes or no. So now it's time to solve the question, students. Question. Okay, let us solve it now. Priti Gaekwad. So the question is in front of you, students. Here, solve this question yourself. I'll not give you in the just a little bit hint of this question. I want you to solve it. Bijapur diamond, I've given it. One student name is Bijapur diamond. Solve this question. It said a system of two charges, Q and minus Q, are at a distance. You have to find the distance and find the dipole moment and sum the charge and tell me what is the total charges. I'm giving you how many minutes? 3 minutes for this. The time starts now. Students. I started the time. Timer is started, students. 3 minutes. Apply your answer in the chat box within 3 minutes. After this, we'll solve one more question and end the class. I want at least 10 answers. I'm waiting for your solutions. One answer has came. One answer has came. Let me see the person who has given the answer. Trupti has given the answer. Trupti has given the answer. I want 10 more answers. Okay, at least 5 more answers. Few answers I want. Then I will go for the solution. Then one more question and then end the class by via MPS. Okay, Tripti and Bijapur Diamond are having somewhat same answers. Tripti and Bijapur, Jensi have also given the answer. Very good, Jensi. Very intelligent students. Very good catching power. Abhishek, one of the answers is fine. Bijapur again, very easy one. Okay. So I'll give you the tough one after this. Bijapur Diamond is saying, Bijapur Diamond student is saying, sir, the question was very easy. That's nice. If you feel like this, the question is very easy. What I'm going to do is this, I'll give you the next question soon. Which one will be, which will be hard somewhat. Not such an average level. Shivu have given the answer. Purnima has given the answer. Good. Very good, students. All of you, this shows that you are really concerned about your NEET and IIT preparations, and also you are very much interested in solving this question. This shows that you really gained the knowledge. Okay, Purnima has solved it. Good. Okay, students. Now I'm showing you the solution here. There we go. I have good. So students, the question is this: there is a charge A at minus 15 and charge B at plus 15. So plus 15 pay, charge B is there, that is minus 2.5. Magnitude of both the charges are same, but the nature of the charges are different. Got it? Magnitude of both of the charges are same, but the nature of the charges are different. So this is 2 into 10 minus 7, 2.5, I mean, same. So the question is same now. It's very easy that we are having a system of opposite nature charges like minus 2.5, 10 minus 7, situated at a distance which is 15. We are not calculating the displacement. Even the displacement here is also same. We are calculating the distance. No problem. Tripti, no problem. Distance is 15 plus 15, 30 centimeters. Here is the one positive charge because it's a system of electric dipole. What is it? It's a system of electric dipole. So dipole moment vector, the magnitude kya hai? Simple magnitude of any of the charges. Don't multiply the nature into distance. Distance you can take meters. Centimeter mein kya hoga? 10 minus 2. If I solve it, this will be 2.5 into 10 minus 6 into 3. This will be 7.5, 10 minus 6. This is 10 minus 1. This will be 10 minus, this is 10 minus 1. This will be 10 minus 8 basically. Okay, let us see the answers. Hai? So if we solve it, total charge, जो कि first question है, it is what? 0. Some Q minus Q is what? Add them 0. Next is this. This comes out to be this. Check your answer, students. Who got the right answer? Send a thumbs up in the chat box. Who got the right answer, students? Send a thumbs up in the chat box. Very good, very good, very good, students. Trupti, Jensi, good Jensi. Okay, Trupti, good answer. Purnima, good. Okay, no issues. Okay, students, now Bijapur Diamond. There was one student, I forgot the name. Bijapur Diamond. Yeah, he was saying that this question is easy. That's good. I see. I don't take my wording like don't mind it. That's good. This shows that you are really challenge. You want a really challenging, above average level question. So this is a question for those students who feel that the previous question was easy. Solve it yourself. You are given a system of charges minus q and q. It means completely plus 2q. Okay, I'm removing this. So these are placed at the vertices of equilateral triangle, 60 degree, 60 degree, 60 degree. You have to find the net dipole moment. You have to find the net dipole moment. Students, I'll give you just, it's given here 3 minutes, but I'll give you just 1 minute for this. I'll give you just 1 minute for this. I want anybody's answer. Even if one person is replying me in the chat box for this question's solution, I mean answer, I'll proceed.
हा आम्हाला 12वी करायची फक्त मला चांगलं वांगाळ बघून ठेवायचंय.
Who is this? Priti, don't do Priti. Mute your mic. Otherwise, I have to, remove this. Otherwise, there's no other option.
हा तिथून पुढे त्यांचं मन काही बी असू द्या, पण मग आम्हाला 12वी करायची आणि मला चांगलं वांगाळ बघून ठेवायचंय. तुझ्या अरे
Okay, 2 of the students have given the answer. That's nice. Okay, let us see it, students. So this was your question, minus q, and minus q doesn't constitute electric dipole, but minus q plus q and minus q plus q, this gives you the electric dipole. So I will say this gives you the electric dipole and this gives you the electric dipole like this. Okay, that is the electric dipole moment vector. So here we are having simple. We just need to vector sum these and we'll get the answer. So suppose if you're having two vectors, A vector and B vector, if they are at some angle, what you will say? What is the net vector? F net vector is equals to how much? It is A square B square 2AB cos theta. Multiply. It's not cross product, it's multiply. Okay. Similar formula we have used here and we have founded the thing. This is the answer. How many students got these answers, students? Please reply in the chat box. How many students got this answer? Please reply in the chat box. How many of you got this answer? Very good. Very good. So students, I hope all of the things which we have studied in the class is clear to you. Let me conclude this here. Okay. So let us start what we studied today. Today we understood that today we studied this thing, that what is electric dipole. It is the combination of equal and opposite charges which are situated at a very less distance. Then we understood that what is electric dipole moment. It is something which is magnitude of any of the charges into distance between them. Direction will be from negative charge to positive charge, that is opposite to the direction of electric field intensity. Okay. Then we studied physical significance, or basically more precisely if I say application of electric dipole or dipole moment vectors via polar molecules. Example is H2O, having the most basic thing is dipole moment is not equals to 0. For non-polar molecule, the most basic funda is how to check whether the molecule is polar or non-polar. Check the dipole moment vector. Cu2 ka dipole moment vector is 0. It's non-polar. Then we solved 2 questions. I hope it's clear to all of you. Are all the things clear to you, students? Please reply in the chat box fast. Are all these things, students, clear to you? Please reply in the chat box fast. Please, students, reply in the chat box. Reply in the chat box. Reply. Okay, students. So if it's clear, I am launching the NPS for all of you soon now. Okay. Thank you so much for. Thank you for attending the class, students. Thank you for attendance. I'm writing in a very bad handwriting. Now I'm launching NPS, students. Please participate in this poll. I will launch the NPS. Please, students, participate in this NPS poll fast. Participate. And if anybody is having any doubt, can ask now. Thank you, Akila. Bye. Bye. Abhishek. Bye. Bye. Trupti. Bye. All the students. Bye, everyone. Bye, Anusha. Bye, everyone. Bye, everyone. Bye, Swastik. Bye. Yeah. Any doubts you can ask. Okay. Bye. Bye, Srujan. Bye.